So here's a release from Anthropic that nobody is talking about, Dreams and multi-agent orchestration. This may sound like sci-fi, but I'll make sure that by the end of this video, you understand both concepts and you know how to apply those to your own Claude managed agents. So to do this, I'll take the example of yet another changelog. It is a block that I already referred to in some former YouTube videos. It is basically an aggregator of all the releases and changelogs from the main AI coding tools out there, okay? So how does it work in practice? This actually relies on sub-agents, so Claude Code sub-agents, okay, that performs the following tasks. So let's take the example of how it works for two of those AI coding agents that I'm connecting to. I have actually one sub-agent called lovable changelogs aggregator.md that is defined by both a system prompt and an agent memory. I'll explain those in details. But basically the gist of it is that it's going to actually scrap the data from the lovable changelogs page. And it's going to actually fetch each of these changelogs and bubble them up, score them as well in such a way they can be bubbled up here directly on the website. This is exactly how it works for Claude Code and actually for all the other AI coding agents out there. So as I said, these two sub-agents, these actually 14 sub-agents, they actually rely on two things, a system prompt and an agent memory. So the system prompt is basically the instructions. So here it is. So for instance, for lovable here, you can see locally how it does look like. So it says that it's an expert web research and content aggregation specialist, and it has specific instructions to actually bubble up data from this specific URL. This is the same thing for Claude Code, and for all the other AI coding tools, I am fetching the changelogs from. So these to date used to work. These used to work only locally, meaning that I would actually spin up a Claude session and I would actually ask Claude to use both Claude Code changelogs aggregator and lovable changelogs aggregator to actually perform the various tasks. So that's not exactly this one, that's actually the agent here, so that's this one, so that they can actually perform this task. The problem is that I need to have my computer on to perform these tasks. Hence why I came up with a setup that leverages Claude managed agents in such a way that these agents are actually spinned up inside a Claude session on the Claude console. That way, I can actually schedule these agents to actually run while I sleep during the night without having my computer on. So here's basically how it works. So I have actually an admin panel here where I can actually manually launch that pipeline. So obviously here what I'm showing you is how I can launch it from the cloud manually, but obviously here I can actually enable a schedule because I mean if I'm able to actually run it manually from the cloud, then it is very easy to come up with a cron to actually schedule that tasks. Vercel does have a native feature that lets you do that. So what happens here is that I'm going to actually run the pipeline here. So obviously here, as you have understood, it only works for lovable and Claude Code, but the real pipeline does work for all 14 tools. And if I run it now manually, so I can choose the days window. So since when I want to fetch the changelog, so I'm going to say since 10 days, okay? And I can use various models, but let's keep it balanced here. And let's actually launch the session here. So what's going to happen is that when I click the launch button here, it's actually going to spin up a Claude managed agent session. So again, that's just like a Claude session that runs locally, except that it is actually hosted inside the infra from Anthropic. Okay, so as you can see here, we have a session here that is running, and we have actually two sub-agents that are launched, which are exactly the two sub-agents that are referred to here, and that are going to complete the task again from the cloud. So we are going to let it run, and we'll see the output. All right, so as you can see here, let me refresh. We have those two sub-agents which actually run in parallel, as mentioned here, that finished up their work, and lovable changelog bubbled up one new entry since the 3rd of May, and with entire summary, etc., etc. And for Claude Code, it was a bit took a bit more time with four new entries bubbled up since the 3rd of May. Okay, So here's how actually multi-agent orchestration works from the cloud. So you have the ability to actually run from the cloud sub-agents that you've defined on a local environment and potentially improved, okay? Of course, I didn't show you here the entire pipeline because the pipeline would require to actually compute the impact score as well as updating the record inside the headless CMS on top of which this website is built. But that's actually the gist of how multi-agent orchestration does work from Claude Managed Agents. But I didn't tell you about everything about how this works. And let me now show you another notion that I actually touched base a little bit at the beginning of the video. This is the agent memory. So of course, these agents here that we used, they actually rely on a system prompt that I showed you. So here in the wake of Claude Code, for instance, we have this one here. So it says, okay, fetch the changelogs from this blog URL, fetch these from this other URL, and make sure to bubble up changelogs, and I have my own definition of what a changelog is. But if you want to make your agents even more powerful, you need to leverage agent memories. So agent memory is actually a memory that is stored for all the sub-agents that run locally based on all the interactions you had with that sub-agent. So these agents, Claude Code, lovable changelogs, etc., I ran them like during weeks. And during weeks, I interacted with them by saying, okay, so this time around you were spot on, but this time these changelogs should not have been bubbled up, etc., etc. And all this is stored as part of a memory that is attached to each agent. So for instance, if we bubble up the Claude Code changelog agent here, you can see that some decisions were made, for instance, on the 7th of May, where 3 entries were saved, but others were skipped, etc., etc. And this actually fills up an entire markdown file that is actually leveraged anytime the sub-agent is used, at least locally. But what you can do now is that you can actually leverage this memory inside the Claude Managed Agents. So how does that work? Well, you need to come up with a script that Claude Code will happily help you with. And what it's going to do is that it's going to actually synchronize this memory.md file to your Claude Managed Agents accounts. And that's what I did for these two sub-agents, which are the Yak Claude Code changelog aggregator and the Yak lovable changelog aggregator. So here, if I click on this memory here, so that's inside the memory stores tab, I do have the entire system prompt here that I actually used to have only on my local environment. And the very interesting thing here is that this memory is going to be called upon for each session that leverage the corresponding sub-agents. And it's actually also going to update that memory. So that's a very important feature to keep in mind when it comes to running on a regular basis sub-agents that you want to keep improving. But the problem with those memory stores is that as you keep running these sub-agents through various sessions, context is filling up quickly inside these memory.md files. As you can see, the size keeps improving, and this can have an impact on the performances, on the number of tokens that you're going to consume. Also, you are simply restricted at some points, or at least Claude Code bubbles up very explicitly that your performances are going to be diminished if you don't clean up these memory files here. And that's where Dreams come in. So as you can see here, I have another memory store here with that additional string at right after the name of the memory store here. And that's actually a new memory for the Yak lovable changelog aggregator that was triggered via a dream. So actually a dream is an agent that runs on your agent memory. Okay, so it runs like autonomously on your agent memory, and it's actually going to clean up the content of your memory based on the past sessions or the defined sessions on which it's scanned whether each or that instructions were used. Okay, so here's what happens. So I can actually manually trigger a dream here via this button. So that's a feature that is in research preview. I got access, and what you can do here is that you can select a memory. So I'm going to select lovable here. I can select the model as usual, and then I can select the number of sessions from which I want the dream to actually run. Okay, And what it's going to do here is that it's going to scan the last 2 sessions, and based on this scan, it's going to actually put forward some changes that they think are required to optimize the content of the markdown file here. So here you see that it's actually pending. I actually ran it before I shot that video, and I ran it on the Yacklable changelog aggregator. And if I click on it, I actually see that there's a new memory.md file that was generated, but I can't really see the difference. So what I can do here is that I can click on the button compare, and I can compare the Dreams memory store, so the new memory basically, with the former one. And that way I can see if there were some changes. And as we can see here, it seems like there were some specific changes that the Dream estimated are not necessary as per the last sessions on which Dream was run. Okay, so once you have done that, what you can do is that you can actually say, okay, so now the Dreams memory store is the last updated version that I want. So I can copy here the content. So it's a bit of a shame they don't have like a copy button here. And then I can actually replace the former content with that new content here, save it, and then I can very well delete the Dream memory store, or just keep it here for just logging them basically. And since my logic here in the application does rely on the specific IDs of the memory stores that are used here, those memories that are stored here will not unpack the logic. The real truth is actually what is stored inside that prompt. Okay, so yeah, that was quite a more complex feature, but let's put it that way. Dreams make it possible to optimize one very important part of your agents, which is memory. And by optimizing memory, you optimize the output out of the costs that will be built for any agents that are run. So again, this is a feature that is in research preview, but I think we can assume this one will come out soon to a general availability. One important thing here is that Dreams, as you can see, I triggered it manually from the UI, but you can very well, with the SDK, connect it to a cron so that it runs on a regular basis, maybe once a week or once a day, depending on your use case. So that's about it for these new features from Claude Managed Agents. If you haven't tested building an agent from Claude Managed Agent, I strongly advise you to do that. This is so much powerful. And I'll see you in other videos to show you about how these features do improve in the future.